Greetings, students. Today we're going to discuss 3.1b. Let's begin. Standard form of a quadratic equation. Quadratic function, sorry. So any function that can be written as ax squared plus bx plus c, where a is not 0, is said to be in standard form. That is standard form. The reason a can't be 0 is because if a is 0, then it's a linear equation instead of a quadratic equation. Now b and c can be 0 in this format. So if b is 0, it just doesn't have a linear term, the quadratic function here. And if c is 0, it doesn't have a constant term. Alright, so the properties here of an equation in standard form. The graph is a vertical parabola if it's in this format with the x squared. So it's an up and down parabola. So the graph is a parabola that faces up or down. I guess you could say opens up or opens down. That's the proper word. So if a is greater than 0, the parabola opens up. Smiley face, because it's positive. If a is less than 0, the parabola opens down. Frowny face, because a is negative. It's a frown if a is positive, and it's mal if a is positive, and a frown if a is negative. And again, a can't be 0, so if a is 0, it's not a parabola at all; it's a line. So we're not going to talk about if a is 0. A is not supposed to be 0. The axis of symmetry is the line through the vertex. All right, so it's through the middle of the parabola. Now, that's going to be determined by how you find the x and y coordinate of the vertex. So the x and y coordinate in this format, unlike in the normal format, for this format you have to do some work to find the x and y coordinate of the vertex because they're not given within the form precisely. So the x coordinate in the format of the vertex, you can find that as opposite b divided by 2a. So you take the opposite of the linear term and divide it by twice the value of the quadratic term. Sorry, not term, coefficients. The opposite value of the linear coefficient divided by twice the value of the quadratic coefficient. And to get the y coordinate, what you'll do is you'll put that back in for x. So the y coordinate of the vertex is f of opposite b over 2a. What that means is for the vertex for this form, you've got to find the x coordinate first, and then you can find the y coordinate by substituting that back in, like a chart, an input-output chart, which I have underneath here for our first example. The nice thing about this format, there's one nice thing about this format, the y-intercept is given by the value of c. So unlike the other format where c is not the y-intercept, c is the y coordinate of the vertex. I was going to say c, but this constant here is the y-intercept in this format. The y-intercept is c, and I should put it as a coordinate, of course. X value of 0, y value of c, and there you go. So the usefulness of the standard form of the function. The first usefulness is it's very easy to find the y-intercept. The y-intercept is very easy when the quadratic is in this format. The second usefulness is if we're looking for x-intercepts. Because it's already factored out, actually not factored out, if it's already multiplied out, we can find the x-intercepts more easily here if this is factorable. Or even if it's not factorable, we can use a quadratic formula to find the x-intercepts. So those are the two main uses of the standard form of a quadratic equation. The y-intercepts, just one, and then the x-intercepts. Alright, so let's find an example here. This one says to use a calculator, but you don't need a calculator to do this. So what I'm going to do here is I'm going to do everything by hand first, and then I'm going to show you how to do everything on the calculator as well. And you can use the calculator Desmos on your phone or on a computer at home. But again, this can be done by hand as well. And for a test, you're welcome to use the computer calculator as well, the Desmos calculator. It could be useful. It will be useful if you learn to use it, but it's not required. In fact, I'll go get my phone and I'll show you on my phone how to use it in a minute here. So for the vertex, the first thing is the vertex. So let's talk about that first. The opposite of B divided by 2A. 6 is the value of B here. It's negative. So we're going to take positive 6 divided by 2 times negative 3. So the x value of the vertex is negative 1. Negative 1. What that means about my chart here, if I'm doing this by hand, is that negative 1 is going to be in the middle. So I've got 3 values to the left of the vertex and 3 values to the right of the vertex I'm going to evaluate. This is my vertex, my x-coordinate, and my vertex. And now what I'm simply going to do with this input-output chart is I'm going to evaluate every value 3 below my vertex and every value 3 above. The first value here in the middle is going to be my vertex value, which will be paired with this x value. And the rest of these values will just be outputs that will help me with the graph, identifying the graph. So I will use a calculator here just to speed up the process of plugging the numbers in. So if you're working on a calculator, phone, or otherwise, I'm working with this TI-84, but the phone you can do a similar thing. So I'm going to do negative 3. I'm going to use a parenthesis here, negative 1 squared plus 8. Or sorry, minus 6 times negative 1 plus 8. So there I've plugged in negative 1 for each of these two x values. And again, I use the parentheses to make sure I don't make a mistake there. So this output's 11. Now the nice thing here is if I'm using a calculator on my phone, I can go back and I can just change that negative 1 to a negative 2, negative 3, and a negative 4. So on the newer calculators I can arrow up, but on this one I have to do something else to get that, what I just typed. On the Desmos you can just retype it on your computer screen or on your phone screen. So maybe I'll go grab that for the next examples. But anyway, I'm just going to change these to negative 2's now. Both of those to negative 2's. And now my output's an 8. Then I'm going to change them to negative 3's. Negative 3's. And my output's a negative 1 now. Then I'm going to change them to negative 4's. And get my new output of a negative 16. Sorry, I had to pause a minute there. I was a little bit confused. So now I can check these 3 values, and the nice thing about these 3 is they'll match these 3. So this is a good way to check if you have the proper vertex, because the 3 to the left of the vertex should match the 3 to the right, because this should be symmetrical with the vertex. Should have symmetry with the vertex. So we'll go back in here. Now I'm going to change it to positive 2, then positive 3, then positive 4. So I have to delete that negative sign. So I'm positive 2 now. Positive 2. Oh, I hope you can see here what mistake I've made on my table. I didn't mean to make this mistake. I'm supposed to only go right 1 each time. So it's a little bit early in the morning for me. Look, I went 3 right away. This should be 0, 1, and 2. So 2 was a value I should have used, but it should have been the last value, not the first value on the right of the vertex. So that is a negative 16, and you see it matches with this one here. And then we'll put in 1 and 0. 1 is negative 1. And of course 0 is 8 because that's my y-intercept. So you can see here that all matches. The y values match. That tells me I've got my proper vertex, which is at negative 1, comma 11. Negative 1, comma 11. So my axis of symmetry, this should be a vertical line through the vertex. So the vertical line through the vertex, so that's going to be x is equal to negative 1. It's not a y equals line because that's a horizontal line. The maximum or minimum is the vertex, and it's going to be a maximum in this case because it's pointing down. So the graph is pointing downwards. How do I know it's pointing downwards? Because A is less than 0, and also because 11 is the highest value here for the outputs. So this is a maximum, meaning that this graph goes from negative infinity and it only achieves a maximum value of 11. This is the y value, not the x value. Maximum value of 11. I'm going to go grab my phone and see if I have Desmos on it or not. I can't remember. If not, I'm going to have to download it, then I'll show you an example in a second. Alright, I got my phone here. Let's see if I got the Desmos app installed yet. I got a phone last year. I don't remember if I put it on this one. It was on my older one. I don't have it installed yet. So I'll install it on my phone here, and while I'm doing that, we'll start into the next example. And by the time I'm done with it, it should be ready to go. Anyway, there we go, it started. So anyways, there's our first example. If you're working on a TI series of calculator, of course you can just graph this the normal way using your y equals key. So if you're working on a TI series calculator, you can just graph this with your normal y equals key, and you just plug it in just like you normally would. Oh, that was really quick. The Desmos opened up really quick here. That's pretty cool. Let me see. I don't want this overexposed, so let me turn down the lighting on this so you can actually see my screen. That looks decent. Sorry, I got this light here. I can turn that light off, and that might work a little better. Yeah, it works a little better. Can't see the paper underneath it, but that's fine. So if you got this Desmos, and again, you can do this on your computer. The computer is actually a little better than the phone version of this. So you have 3x squared, and notice it's graphing as I go along. And if I make a mistake and forget to put the negative in the front, I can just go and put the negative. The negative is the minus sign on Desmos. So you don't have to worry about, messing up the minus sign and the negative sign on Desmos because it's the same. And then you have minus 6x. And then you have plus 8. So the nice thing about Desmos, let me zoom out a little bit here. You zoom out just like you would, with a photo. The nice thing about Desmos is, look, it's labeled the vertex here for you. You can click on it or tap on it with your finger, and it says there negative 111. It also labels the x-intercepts, which I'm not asking you here on this question for you, which you can tap on them with your finger and get the values. To get the other values on the table here from the calculator, or from your phone, I guess you could say, it does have a way to do that. Let me think. What's the way to do that? I can't remember. Is it under the arrow? And then table. It's under that wheel, and it's this guy right here, the table function. And then you can scroll up and down with the table here and find in the outputs. So you see it started at 0 for me. So it started at 0. I actually wanted to start at -1, but it does give the values. It's just you gotta go work for them a little bit. All right, and I think it can scroll if you put in different values here. I think it can scroll. Yeah, you just gotta put in different values, backspace, and put in the value you want. So if I wanted -4, I just put it right here, and there you go. Okay. So this is probably the best option for most of you, the Desmos option, which again is on the computer too, on the Chromebook. Just look up Desmos, and you don't need to install it on your computer, just on your phone if you want to use it on your phone. So that's the best option for these if you want to do them on a calculator. Anyways, so I'll do that for each problem too. I'll try to go through the both the steps. Let me turn that light down a little bit. Don't want to overexpose it. That's where I want it. Right there. Alright, so moving along to our next example. So here's our procedure for graphing a problem in standard form. Determine A, B, and C. Determine the shape of the line graph. So does it point up or point down? Determine the axis of symmetry. So what is the vertex basically? The x-coordinate of the vertex. Then find the y-coordinate of the vertex. Then plot the y-intercept. Then find the reflected point and sketch the curve. So this is the easiest procedure to graph one of these by hand. So to graph one of these by hand, I'll start off by saying in this case A is 1, B is -4, and then C is also 1. This one's going to point upwards, so I'm going to keep in mind that this points up. Smiley faced. Why does it point up? Because A is positive. So next thing is the axis of symmetry, which is the x-coordinate of the vertex. So we're going to do opposite B divided by 2A, which is equal to, well, B is -4. The opposite of -4 is +4, and then 2 times A is 2. So that's 2. And what this is going to give me is my vertex. So now I can make a small t-chart, just a small one, with 2 in the middle, and then 1 and 3. Why 1 and 3? Because I want left and right of the vertex, a point left and a point right of the vertex. Okay, so now I'm going to put this 2 in for x. Here, 2 squared minus 4 times 2 plus 1. Again, I can use a calculator for that portion. So let me quit out of this. 2 squared minus 4 times 2 plus 1. That value is -3. And again, it's always useful to use a calculator here because you're going to have to put in these other 2 points as well. Anyhow. So then I'll go back. And what I'm going to check here is when I put in 1, and get its output, oops, put in 1, not 2, of -2, I want to check and I want to make sure that 3 has the same output. So if I put in 3, is this the same? It is. So here I've got what I need to graph. Now for these other 2 points it said here, you could instead find the y-intercept and reflect it. That's also acceptable. But when you do the y-intercept, make sure you keep it evenly spaced from the vertex, your other point. So if I use the y-intercept of 0, 1, the other point would be 4, 1. I prefer to do this, just for me, because for me it seems more standardized. But you're welcome to do the other way as well. So what do I have here? I have 3, -2, 2, -3, 1, -2, and there's my graph. I can point, and it's pointing upwards, so I can point this upwards. The curvature is not particularly as important as the 3 initial points, but the other point here, like I said before, is 0, 1, and then 4, 1. Now again, alternatively, if you prefer to use a graphing calculator, it's very easy to get a graphing calculator here to work properly on your phone. So I would just do, so again, for here, I'm going to do my graph here, which is x squared. Sorry if that's a little overexposed, but I'm not going to turn off the light each time I need to do this on the calculator. I showed you the first time real well how to do it. Minus 4x plus 1. So again, here's my graph, and you can see here, oops, you can see here if I zoom in on it, just like you would on a normal photo, you can get the points pretty easy just by, clicking on them. That one I'm not going to use as one of my points. That's the x-intercept. Zoom in so you can see what I'm doing, because it's 2.6, 0. But this one up the bottom, that's a good one to use, -2, 3. That's a good one to use. -2, -3, and then I could use this one over here, 0, 1, and I could also do the table if I wanted to, table here. And I could look at the points on the table and determine, oh, here's my vertex 2, -3, and then 1, -2, and then I could use this point here as a 3, -2, change it. So again, you're welcome to use a calculator, and the Desmos is probably the best one for this, for most of you, unless you have a TI calculator already. Okay, so here we got a new one. The difference about this one here is that this time the vertex is going to be fractional, which does present a little bit of a problem. I'm not going to lie to you here. the problem that it presents is finding the y value of the vertex. So A here is -2, B here is +2, then C is -5. Now I don't know why these ones have different items to ask. This is from last year's tests. So sometimes these items are asked specifically, sometimes you just find them. But you're going to do the same thing each time. So do opposite B over 2A. Opposite B divided by 2A. So B here is 2, so -2 divided by 2 times -2. So like I said, this is fractional. Excuse me. So that's a 1/4. -2 over -4, 1/2 I meant. So that's my axis of symmetry, and it's also my x value of my vertex. The issue here again is finding this y value. That's the only real issue here. So when I do my table here this time, x and y with 1/2 in the middle, you don't need to go by 1 each time. You just need to have it evenly spaced. So since this is a 1/2, I can use 0 and 1 here as my other two, because that's actually evenly spaced from a 1/2. Alright, so plugging in the 1/2, again I would recommend using a calculator here, but you're welcome to do it by hand too if you'd prefer. So -2 parenthesis 1/2 squared. 1/2 is 1 divided by 2, or it's 0.5. So there's a 1/2 squared. Plus 2 times by 1/2 minus 5. Alright, so that's -4.5. -4.5. Alright, then I can go back in and I can plug in 0. If I plug in 0, it's just going to give me the y-intercept, -5. And then let's plug in 1 and make sure I get the same output. And again, it's pretty easy to plug in 1 by hand actually here. But if you'd like to be sure, use your calculator. And you can do the same thing on a cell phone. There's nothing special here. -5. So yeah, that makes sense. You see how those matched? So that tells me, yeah, I've got a good table. I've got a good graph. So I've got -1, positive 1/2, -4.5, which is here, kind of in the middle of both. It's in the middle of both. 0, -5, and 1, -5. Oh, I forgot to put that this point's down. Why is it pointing down? Because A is negative. So what we're going to do, points down, frowny face. So there we go. Again, the curvature here isn't nearly as important as the 3 initial points. Getting the 3 initial points right or correct. Alright, so for my axis of symmetry, or my vertex, -4.5 here. Alright, so for my axis of symmetry, x equals 1/2. For my y-intercept, it's this value of 0, -5. And it's asking me here for a reflected point. What that would be is this other point that matches that y-intercept, 1, -5. If I was asking for a reflected point there. And again, you're welcome to graph this on your phone on Desmos, and it will give you the same graph, and you can just touch the points that you're looking for, and then use the table function to get the other one. I should say touch the vertex to get the vertex, and then use the table function to get the other ones. It's pretty self-explanatory, the Desmos calculator. Alright, so there's this, page 100. We got a couple more pages here, mainly of sample problems. So let's move on. This one says find the vertex form. What this means is factor. And actually I should probably put instead of factor, it means complete the square. Complete the square. So this can be quite tricky. It can also be kind of easy, depending on how the questions are set up. So the steps here, if you have an A term, you're going to factor it out. So step 1, factor out little a. So we'll do both these samples at the same time with the steps, so you can kind of get the steps, in order. So here A is 2. We're going to factor out the A term. Now the nice thing is we don't have to do anything with this constant, factoring out the A term from it, just from the linear and the quadratic term. So I'm going to do 2 factored out from x to x squared, so that becomes just a x squared. So I take this a in the front, minus 4 factored out, and that factored out from the 8, the 2 from the 8 to make a 4. Now as you're factoring out this a term, so this one's negative 1 times x squared. Now this will become a negative 4 now, because I factored the negative 1 out, because a was negative 1. So as we're factoring out the a term, what we want to do is complete the square. So I'm going to add in a blank plus this unknown value. I'm also going to subtract that unknown value outside of the parentheses. So this is the part that's going to factor nicely. This is going to be, well, this is going to be subtracting off whatever I put in here so that I don't change the value of the equation. And then I'll have my constant at the end. So I'm going to subtract off that same value and put my constant at the end on both of these. Alright, so again, this blank is what we're adding to complete, adding and subtracting to complete the square. We're adding and subtracting this blank, this unknown number. We haven't figured out what this number is yet. So as we factor out a, add and subtract. Do you remember what we need to add and subtract to complete the square? What value? What numerical value? The numerical value we need to add and subtract is half of this value squared. Now we would usually call it b, but you see here there's a constant in the front. So this isn't actually the value of b. b was negative 8 here, and b was positive 4 here. So I'm not going to put half of b squared here, like we would normally put. It's half of this middle term squared. So half of the middle squared. So in this case I'm going to add and subtract, on both of these I'm going to add and subtract 4 inside the parentheses. Now when I subtract 4 here, it's actually subtracting 8 because there's a 2 in front of that 4. So I'm actually subtracting 8 here. And here I'm actually adding 4, because look, negative 1 times 4, that's actually a negative 4. So I'm actually adding 4, which is kind of confusing because these are both plus. But that's because a was negative. Alright, so that's the setup in order to complete the square. And then this will be a perfect square now. You can see this is x minus 2 for both of these. So now we have f of x equals 2 times the quantity x minus 2 squared minus 11 for this first example. And for this second example, f of x is equal to negative 1 times the quantity x minus 2 squared minus 1. Okay, alternatively, I know that was confusing to a lot of you. Alternatively, if you have access to the Desmos calculator, which you should have if you have a phone or a Chromebook, either one, let me show you what you can do alternatively here. So let me get rid of this one. Again, you just got to click the X to get rid of them. I just click the X there. Graph this. 2x squared minus 8x minus 3. So graph it. What am I looking for here? Specifically, what does it ask? The vertex. So find the vertex. What's the vertex? Again, you find it by tapping on it. 2, negative 11 is the vertex. You can write the equation of this parabola, so 2, negative 11. And again, its x value is always opposite. We talked about that last class. So here is the vertex, and then what goes in front? The value of a. So the alternative approach here is simply to graph the parabola, finding its vertex, and then put it into the form. So the form you're using here for both of these would be the format, the vertex format. F of x is equal to a times x minus h squared plus k, where h is the x coordinate, positive 2, and K is the Y coordinate, negative 11 of the vertex. So that's the alternative approach here to doing these. I find this approach actually easier than completing the square, but I wanted to present both so that you could have an option. This one for me is a lot easier than completing the square though. Okay. So here's some sample problems, like SAT problems or ACT problems. So this is a performance of a stock. So D represents the days of trading, and P represents the price per share. So what do we notice first about this stock? It is going down in value. How do I know that? Because A is negative. So this one points down. So what I'm going to first off talk about here is this points down, because A is negative 3. A is negative 3, points down, and B is 50. So what that means is this is going to have a maximum price. It's not pointing upwards. If it was pointing upwards, it would have a minimum price. So what is the maximum? Well, it's the vertex. The maximum price is the vertex of this stock, which you can find using your graphing calculator. So let me just do this one with the graphing calculator directly instead of doing the equations. So I'm just going to get rid of that one. So negative 3, there's no D on my calculator, that doesn't matter, I'm just going to use X. Negative 3x squared plus 50x. So there I have it graphed. Again, I'm going to have to zoom out until I can find my vertex. But there's my vertex all the way up there. As I go all the way up to the top, I see my vertex. Well, what value is that? So I'm just going to, find my vertex, zoom in like I would a photo, and then just touch it. So that is the maximum price. So what does that value mean? It means at 8 1/3 days, the stock trades at $208. So my maximum price is the Y value here. $208.33 is the maximum price per share. And again, I could have found that by doing opposite B over 2A. The opposite of 50 is negative 50. 2 times negative 3 is negative 6. So 50 divided by negative 6 is 8 1/3. Then I put 8 1/3 in for D here, and I get the value out. So if I wanted to do that way, I would say opposite B over 2A is equal to negative 50 divided by 2 times negative 3, which is going to give me 8 1/3. And then I'll put that value in for D here, and I'll get this $208. So then I would do negative 3 times by 8 1/3 squared plus 50 times by 8 1/3 to get this $208. Alright, so there's example 6. And then our last example. Sorry if I went a little bit long today. It looks like I went about 33 minutes. My goal again is usually go about 30. Sometimes I just go a little bit off. So here is the bridge. The New River Gorge Bridge in West Virginia. It's the world's largest single arch bridge. Not the longest, the largest. You can model the arch with the function, and here's a function for its model where x and y are measured in feet. Approximately how high above the river is the bridge? So again, this parabola points down. Look, A is negative. So again, what I'm looking at here is a maximum. Points down. So I can graph this on my calculator, or I can do the opposite B over 2A by hand if I prefer. So I have here, let's get rid of this guy. I don't want him anymore. We have here negative, sorry, gotta get my negative sign, point, I should do 0 point. Doesn't really matter if you do 0 point or not, it makes it look nicer. 0, 0, 0. So 3 zeros is 498 x squared. Then plus 0.847 and an x. So there's my graph. Now I don't see anything on my screen. Well, that's because I'm in the wrong spot. I'm not looking for where I need to be. So again, I'm going to have to find where we're supposed to be. And I know it's a maximum, so it should be pointing down. So you can see here as I'm zooming out, I can finally find it. I just got to zoom out and out, zooming out and in. So I just got to zoom out enough and I'll find it. And then there it is. I can click on, I can touch the point, and it says here 360.1545. And that's when X is 850 feet. So this is 360. And it says here to approximate to the nearest feet, about 360 feet. Now the last thing here with this question, this is an SAT question type deal. The arch is actually built on the cliff edges above the river. So the bridge is only 360 feet tall, the arched portion of it, but it's 516 feet above the river. So I need to add that extra 516 feet to that 360 to get its total. So the actual bridge is 876 feet above the river. So if you were to jump off the bridge, you'd be jumping off 876 feet, not the 360. The 360 is just the height of the arch, which is connected to the rocks on the sides of the river. Anyway, so that's what I would recommend for this particular unit, to use the Desmos calculator on your phone or on your Chromebook. It works the same way on either one. It's pretty much the same. On the Chromebook, when you zoom out, you actually have to zoom out with a button, which is on the screen. I think it's pretty easy to determine which button to use to zoom out. There's a little plus and a minus on the Chromebook or the desktop version of Desmos. But on the phone version, because it's like a photo, you can zoom in and out just with your hands. So if you're using this on your Chromebook, there's a little plus and a minus that you can zoom in and out with it, instead of the photo type deal that Desmos has on the phone. Anyhow, good luck. Thank you for paying attention.